Thank you so much, Mark. This has been such an incredible conference so far, and I'm so thankful to be here. So hello, I'm Charlotte. I sometimes describe myself as a creative technologist and maker, which is like the wankiest title I've ever invented for myself. By day, I mostly am a front-end developer at a startup in London, but by night and on Thursdays and Fridays and weekends, I make generative art and I turn it into real-world stuff. So today I'm going to talk through a couple of my projects that cross that boundary and hopefully show you a couple ways that you can use your coding skills to make cool real-world things as well. But firstly, why should we use computers to make art anyway, especially physical art? We think of art as being a very expressive process, and adding this like weird binary middle step of computers seems kind of incongruous to that. But I want to argue that computers actually are better adapted to the design process than any kind of traditional medium. So if you have this cycle, if you're making like a table or something, every iteration you get to build, and you have to build the table from complete scratch. But with code, you get to build off whatever you already have and make as many copies as you'd like along the way. And I think we often forget how bloody magnificent that is. They're carbon copies, perfect recreations, completely infallible, which is something you can't do in the physical world at all. Imagine building a table and then having infinite copies of that table. And more so than that, imagine being able to vary every single one. That would be incredible. When it comes to making physical things with code, usually this involves writing code to tell a machine how to make something. So there's still like a time factor to that. It's not going to be instant like it can be on the web, because you have to manually make the thing, but it's still a lot less laborious than carpentry, I guess. I want to start by talking about CSS. I love that we've been speaking about CSS already today. I think there's a perception that generative art is very math-heavy, very JavaScript-heavy, and I want to lower that barrier and show you, as well as myself, that you can make generative art just with HTML and CSS. So here is a grid of white squares, and inside of each square is a black circle, which is twice the size of the square. Because of the default positioning, they're all in the top left, which makes this kind of weird triangular cutout. This is already showing the key quality that makes generative art possible. We only have to write the styling for that grid item once, and it gets applied to all of these things. So forget that I had to write div 100 times. No, I use JavaScript to do that. This is all a lie. So repeatability, as I was saying, is one of the key concepts that makes generative art possible. But doing the same thing over and over again can only get you so far. There needs to be some sort of input for genesis, and that can often be randomness. We don't have randomness in CSS, sadly. Or some user input like touch, but I don't want to make art that you have to hover over. No offense, Cassie. But we do have this one pseudo class that can make things look kind of interesting, and that's nth child. Ta-da! Yeah, this isn't doing a lot right now. It's just for every second square, it's anchoring the circle inside of it to the right-hand side, which makes these semicircles. But if we turn that 2n to 3n, we get this pattern, which is starting to look pretty interesting. You can still see that it's a grid of squares, but there's something much more alive about it. And that's the joy of generative art. It's like finding these unexpected outputs by just tweaking the input. It's a visual result you don't expect from just 3 extra lines of code. And we can keep going with this. This time we've added another nth child modifier, which anchors the circle to the bottom of every second one, which means every 6th square will have the circle in the bottom right. So by layering up these nth child things in higher orders, we can kind of simulate randomness with CSS, which is pretty cool. This feels really different to me from the previous one. And we can just keep going, modifying these. This is just flipping that 2 and that 3, and it's making completely different shapes already. This is with 3 and 4. I really like this one. You get such different patterns every time. And I was playing around with this for a while, trying out different amounts of rows and columns as well. And I thought, I'm weirdly proud of this. I want to show it off. I think this would look really cool, like etched into glass or something like that. But we're keeping it low level here with the CSS. So I thought I'd keep the production low level, I turned on my HP Envy 5540, and I pressed Control P, not Command P. Sorry for the slight delay, my laptop did not want to behave with the system here, but I am a Windows girl through and through. Anyway, I made this. So we're going to get onto all of the cool machines that make digital physical art in a bit, but I want to take a moment for the humble desktop printer. It's definitely the most accessible piece of equipment I'm going to talk about. I think most people have access to a printer, and if not, you can go to a print shop, and it's like 10p for an A4 sheet of black and white, so it's pretty easy to do. So with this, I just printed them off in my studio, sandwiched them between two pieces of plastic, nail in the wall, hung them up. And this was opposite my door every time I entered my old studio. And it made me so happy every time I saw them. It made me feel so creative because it made all these really interesting shapes, but each of them was about 20 lines of code, which is kind of crazy when you think about it. The physical presence of having something you've made yourself, decorating your space, is really powerful, and clearly it doesn't have to cost a lot. Besides making cool, abstract decorations, I think printing is really useful to give context to a project. It's a bit of an aside, but I think we kind of forget that computers are a transient medium, and they're constantly mode switching. So even though mentally you can remember that like these variables will result in this output, or this page, when I click that link, will go to this page, like you can never see those two things at once. Printing things out is the only way to get like a real-world context for those kind of projects. I like to go so far as to print out entire websites. This was a client project I was working on. They had a lot of mismatched styles, and I was building a component library for them. I promise this isn't going to turn into a design systems talk. But everyone thought I was really excessive when I printed out the whole website. But for me, this was a very obvious way of finding the inconsistencies without having to like click through every page. So I just want to encourage everyone to print things off more, please. And if you can offset the carbon or whatever if you don't want to waste the paper. Speaking of wasting paper, pen plotting. Let's move on to that. So this was me and my new studio the other week. It's so soothing. I could stand here for this entire talk and just watch it paint. I'll leave that there to hypnotize you. Pen plotters are mechanical drawing devices. They tend to have an X and a Y axes, and some device to like lift and drop a drawing implement. They were really popular in the 70s and 80s for large format printing, especially for architectural and engineering drawings. But they kind of fell out of favor when inkjet printers became like a lot cheaper and more efficient. In the last couple of years, they've had a massive comeback. A lot of artists and hackers have realized how cool they are, and models from the 80s remarkably still work really well. I think they've all dried up on eBay now. But there's a company in the US called Evil Mad Scientist who make these high-quality models. They're specifically geared towards digital artists and hand letterers like Seb Lester. There's quite a wide spectrum of pen plotters available these days. There's so many on Kickstarter, and some are on a lot cheaper side, but as far as I can see, nothing matches the build quality and consistency of the AxiDraw, which is what this is. I bought this about 5 or 6 months ago, and I absolutely love it. This is the A3 AxiDraw. It costs £550, which is like 650 euros. So yeah, it's a fairly hefty investment for a hobbyist. But for me, this is the kind of device that really encourages me to be creative because I find the output so tantalizing. I was saying before about how the digital world is distinct from the physical world because it has this perfect repeatability, which is kind of a shame because it means there's no like space for inconsistencies. There's no room for serendipity. But with pen plotting, you can have like a millimeter perfect detailed plot, and you're still going to get these little spots where the pen over-inks when it hits the paper, or the lines aren't particularly even. And I think that's what makes these pieces so gorgeous. When you look at a piece from a pen plotter, you can feel the hours that have gone into it, and even though they're not human hours, I think it's really beautiful to be able to see that intention go into a piece of art. So throughout this talk, I'm going to have a couple of practical tips to point you in the right direction if you want to dip your toe into this world. So practical tip number one, if you are planning on getting into pen plotting, I urge you to get some thin, cheap paper and test all of your plots first. I cannot count how many I've had to just chuck out because I haven't had the pen at the right height or something in the file was messed up. And it's really easy to go wrong. So to avoid having to do the entire plot twice on crappy paper, I have a template that I use to kind of calibrate the machine. It has crop lines in, like 1 centimeter in, to make sure it's like aligned properly, and then I draw lines across the whole thing to make sure that it can draw across the whole thing. It doesn't randomly dip down in bits. And then I isolate like one bit of the final thing and draw that on to make sure you've like picked the right pen and that kind of thing. Practical tip number 2, use this NPM library called Canvas to SVG to get your canvas art into a vector format. So here is an illustration. It does pretty much the same thing as the CSS one, but in JavaScript with the Canvas API. It's a lot more maths, pretty much unreadable. Don't worry about understanding it. I just kind of played with the variables until I got something beautiful. Canvas allows us to use the GPU to draw primitives really performantly directly into an HTML element. So here we're using quadratic curves. Don't know if you can see that. But you can use rectangles, circles, other types of lines and curves, and then you either fill them for background color or use stroke to outline them. And that's how, just like layering those up is how most of the cool generative art you see on the internet is made. So the way it works is we make a canvas element, and then we get the rendering context of that element, and then we apply all of these things to it that draws out. But yeah, the issue with this is that canvas element is a raster output. Canvas is a black box, is what Cassie said yesterday. And it's actually kind of cool because you can right-click on a canvas element and save it, and it will save as a PNG. So if you want to like print it off, you can do that. But for pen plotting, you need some sort of vectorized file. So that's where this lovely library comes in, where you create a canvas to SVG context with the same size as you would of a canvas element, and then you can apply, it has all of the same methods as a 2D canvas rendering object, but then you can also export it as a serialized SVG, and here I just saved that and downloaded that as an SVG directly. But yeah, following on from Cassie's talk yesterday, SVG is really, really cool, and beyond just downloading this for something like a pen plotter, there are many cases where, for the developer experience, it's actually nicer to build in JavaScript using Canvas like this, but actually in the client, it makes more sense to render it as SVG. Because then you get all of those automatic wins. You can animate it with CSS, change the colors of CSS, and you also, instead of with Canvas, you have to do like a really complicated resizing event thing to make sure it's rendered at the right scale every time. But if you just output an SVG, you get all of that built in. So that's pretty cool. This library also works with Node Canvas, so you can run it in on a server if you wanted to. I haven't quite figured out why you'd want to do that, but there's got to be a good reason. Cool, now we're ramping up to laser cutting. But first, I want to talk about jigsaw puzzles a little bit. This colorful thing in the background is an evolution of one of the first pieces of generative art I ever made, like 3 or 4 years ago. It's not the most complex piece of art ever imagined. It just has some kind of colorful circles that leave these duotone trails. But ever since I made it, I thought I'd make a really good design for a jigsaw puzzle. So for the last 2 years, I've been like very sporadically working on creating generative art jigsaw puzzles and actual products you can buy. Honestly, not too far along that process. But if you want to sign up to my mailing list, Abstract Puzzles 2020, someday it's going to happen. The challenge for designing jigsaws is about balancing simplicity and complexity in the design. You want all of the pieces to be unique, but you also want there to be some sort of obvious way of grouping them. And I think colorful abstract art is a really fun way of fulfilling both of those criteria. Plus the idea of having every single puzzle be a completely different design is really cool. Second element to making generative jigsaw puzzles, is how you cut the pieces. I don't know if anyone here has ever written an algorithm to randomly generate jigsaw patterns. Anyone? This is not very likely, but if you are, you're my hero. It's what you should spend your weekend doing, because it's really fun. And this is why I love creative coding so much, because you can be very expressive making generative art. But this is more like generative design. There's some sort of boundary there. There's a framework you have to work within. And whether that's like a material limitation or something like this, which is a product convention, you get to come up with all these creative solutions to those problems, which is great fun. So most of the jigsaw puzzles you can buy are made out of recycled cardboard and are cut with a big metal die. It's like a giant pastry cutter that just stamps through it. So a lot of jigsaw companies will only have a handful of these die in different sizes because they can last tens of thousands of cuts before they dull. But the downside of that is that you can't vary the design between puzzles because obviously the die is in a set shape. So the alternative is laser cutting. By the way, this is all developed in the browser, just like with the penplotting example. I used that canvas SVG library to get the output of laser cutter. You might be able to tell from this rather smoky video that I'm kind of still working out the kinks in this method of production. Making things is really rewarding, but often super difficult and frustrating because you don't know what kind of complexity is going to be thrown your way from the material or the method of production. Like with this, I wanted to use 6mm MDF, which is medium density fiberboard. It's like a wood composite material. And that's because it's a very consistent material, and 6mm is nice and chunky for a puzzle. But it's hard to burn through that density of wood without it getting really smoky. Usually you wouldn't have to worry about that, but with this, in theory, I have a picture of a puzzle printed on it already, so you need to care about the smoke because that might affect the puzzle. And then there are so many other variables as well, like what are you printing the puzzle design on? Like how thick is that paper? How do you mount it onto the wood? Do you want to have it face up or face down in the laser cutter? There are all of these aspects that it's really annoying to work with physically because in code you can just, it's just refresh. And with here it's every single step is quite a bit of time and quite a bit of money. But just like in code, if you try hard enough and just don't quit, you'll get there eventually. So yeah, abstract puzzles 2020. I've been cutting puzzles out of MDF and plywood, but you can laser cut out of all sorts of materials, and they have some really interesting results. So this was a project inspired by a place in Florida called Cape Coral. It's the city in the world that has the most navigable canals. It has 400 miles of canals, which is bananas. Like every single house is on a canal. So from satellite, it just looks like a giant maze. So I made some mazes and also an algorithm to like as if water was spilling to see how it would disperse. Side note, mazes also incredibly fun creative coding challenge. There's a really great book on the topic called Mazes for Programmers by Janice Buck. Would really recommend that. Paper is really fun to laser cut because you get very, very neat edges, and because it's so thin, it takes barely any time at all. So you can make very complicated, intricate patterns, and it'll happen really quickly with basically zero effort. The downside is paper's really delicate. I didn't really think about that when I made mazes, but trying to pick up a sheet of something where everything only connects to one thing, very, very difficult. No, that's fine. I also did some material tests with foam board, which came out quite interestingly. Foam board is foam sandwiched between card, so it laser cut through both of them really easily, but the foam kind of melted and retracted, so it made these kind of different levels on the foam board, which I thought was really interesting. This isn't actually generative art, but I just wanted to show that you can also etch on a laser cutter, which can have really interesting effects on acrylic and wood. So this was a quick drawing I made with just a thick marker pen, just doing some sort of squiggles. I scanned it into the computer and brought up an Illustrator and outlined each of the pieces. And then I etched it back into wood and then cut through where the outlines of each one were. I was then able to take those pieces and rearrange them on a flatbed scanner and bring them back into a digital space. And I think that kind of interplay of digital and physical is really exciting. You can use tech to further your art and art to further your tech, and they can both be very complementary to each other. Practical tip for laser cutting, get access at a Hackspace University pay-by-the-hour facility. Laser cutters are extraordinarily expensive. The one I had at university cost £60,000. You can get cheap ones as low as like 200 quid, but I really wouldn't recommend that because they're lasers, they're very dangerous. They also need proper ventilation for them. But also, if you get a cheaper one, they're going to be less powerful, so everything you do will take a longer amount of time, and there are quite a few trade-offs there. You're just probably better going to a place that has a good one already. So if you're a member of a university that has any sort of design department, well, at least in England, but I feel like laser cutting technicians just really want to share the joy. So even if you're not part of that department, you can usually ask for an induction and have access to that. Otherwise, there are hackerspaces around the whole world which have tons of equipment for metalworking and woodworking, digital prototyping, all of that. So there's a wiki called Hackerspaces, which is a compendium of these kind of places. It lists 20 in Berlin. Probably not all of them have lasers, but some do. There's one actually just across the park called Motion Lab. I've looked them up. They have loads of 3D printers, loads of laser cutters, look really cool, and it's like 200 yards that way. They're often kind of subscription-based clubs, so you pay something like 40 euros a month to have access to all of their equipment. With laser cutters, there's usually also an hourly fee because it actually uses up a consumable part. But they're also very community-oriented spaces, so a good place to like learn new skills and meet people that are into similar things. There are also plenty of places where you can just straight up pay by the hour for a laser cutter. That's what I'm doing at the moment. You obviously need to have done some laser cutting in the past. They need to be able to trust that you're not going to break it. But that's pretty great and easy to just be like, I want to do some laser cutting today. I'm going to book in an hour. My second practical tip is that test-driven development still applies in this context. You may think you can come in with this perfect idea, wonderful SVG that you've exported, but like it probably isn't going to cut the way you'd expect it to. Lasers have both power and speed settings. Usually next to a machine it'll have a list of common materials and what that will equate to. But there are loads of different reasons that might not be the case. Like it might cut perfectly at one edge of the laser bed and not work at the other, not go through the whole material. And also it's really hard to know what material is actually appropriate for your job without trying some first. So I'd really recommend, if you want to do some laser cutting, just bring in a few materials and just cut out a load of circles and find the setting that works best for the material you want the best, so you can be really confident when you're cutting the actual job that it's going to be successful. Ooh, 3D printing. I'm getting more and more excited. Oh, is this not going to load? That would be a real shame, because I'm going to talk over this for like 5 minutes. Oh, am I going to not have any demos from now on? That's unfortunate. I'm not sure there's anything I can do about it. Help. No, they're all like they're all demos. They're on the file system. I don't know how to get out of that. Well, anyway, I can tell you what I was going to talk over the slide on anyway. To give context to this project I'm just about to talk about, just to help give you a little bit of background for me. I actually have a degree in jewelry design and silversmithing, which is where my obsession with touchy things came from, I guess. But while I was doing that degree, I was working as a web developer part-time always, and when I finished that degree, I was kind of leaning more towards a career in web development than jewelry, because jewelry is a very painful industry, and I was already like an okay web developer. But I was really dissatisfied with my creative output on the web. I really like the problem-solving aspects of making websites, but without having any kind of like touchy-feely thing, it didn't really do it for me. So this is when I started finding out about generative art on the web, seeing all of the like cool creative stuff you could do. And I found a master's program at Goldsmiths in London called Computational Arts that was really cool. It was all about bringing other aspects like audio and robotics and making physical stuff like I do. So I decided to undertake this master's. And at the end of our first term, we had a class about simulating biological phenomena, which you would be able to see and hopefully will be able to see.
Yeah, we're working on it.
Cool.
I can dance for you.
I can riff for another minute. But yeah, we had this actually. There was. It was a course more aimed at kind of like artists that thought that code could help them with their practice. So there were a lot of people that were very hadn't done a lot of code before, and for me and a handful of people that were like okay developers, we found it really, really slow. So we basically made this offshoot class, and they just were like, oh, have this PhD guy, and he can teach you some stuff about simulating biological phenomena. And we were all like, yeah, sure. So we did that, and we learned a lot about like flocking and like voids and like physics models inside of code. Can you open them just as HTML files? Where's the mouse? No, it doesn't need to be online. It's just, there's going to be some JavaScript that's not working right now. Oh, maybe they do need to be online. I downloaded them all earlier and they're fine. Can you get online?
Pardon?
Can you get online?
Yeah, we can
Sorry. Thank you. Yeah, computers haven't been my friends today.
Oh, not today. We are online now.
Yeah, so this should just work. It's thinking.
We're kind of online.
It's thinking. I don't know what it's trying to connect to. I think it didn't all transfer onto that USB.
Mm-hmm.
So maybe it's trying to get to a file that isn't even there.
On the USB again?
Maybe it didn't all make it to the USB. This is where I'm setting.
Should we try it again? Get it on the USB?
No, I can show something else. I'll figure it out. I don't know how to type on this weird keyboard, but I'll make it work. Just show you a collection on CodePen. Where are the slashes? Slash? Oh, I didn't spell CodePen right. Oh god, this is it.
Icelandic keyboard, so it's not. An Icelandic keyboard, not her computer. And slow internet.
Yeah. It's fine, we'll make it work. This has other stuff in it. I wonder if any of those demos work. Hey, that's something. Hey, there we go. Thank you. Should we just leave it? I feel like we don't want to tempt fate anymore. Screw the notes, it's fine. Okay, let's go back one step. Is it going to let me go back one step? I'm touching the wrong thing. Yes, okay, right. This is what was supposed to be on screen the whole time I was doing my spiel about my background. Any fans of Conway's Game of Life in here? No? Yeah? Couple? So, yeah, this is Conway's Game of Life. I didn't explain that at the end of this term project, we had to do something with all of the knowledge we'd learned. It had to be on a screen, which is kind of confining for me, but they're basically like, use some of this stuff, combine some stuff, make something. So one of the things I wanted to use was this, which is Conway's Game of Life. It's a really basic biological simulation where every generation, the the little bits turn on and off based on how many are on or off around them. So they can die from starvation or overpopulation, but they can also generate from having the right number of neighbors. I can start it again and you'll see. So this kind of reduces into quite a nice equilibrium, and it's just a kind of magical thing. So I wanted to do this, but I wanted to do it in hexagons because hexagons are awesome. I just thought they have more sides, so there's kind of more room to play with there. Didn't really think about the fact that hexagons actually have fewer neighbors than squares because squares are counting the diagonal ones. But anyway, this didn't work perfectly. There wasn't the right combination of settings to make it kind of keep going. So I had to like randomly turn on a hexagon every now and then to keep it in state. But those were two elements. The third one, I'm not even going to try and pronounce this word, I'm sorry. This is the generative design book, which was originally written in German. Really fantastic, chunky textbook with loads and loads of creative design projects. Would really recommend it. One of the things from there was this, which was a Cartesian grid, and it was a drawing program, so you could draw on these cells, but what was shown inside the cell depended on what was active around it. So you could just drag across the screen and it would make these really interesting shapes because of the way the glyphs worked on it. So I wanted to combine all these three things, and this was step 1. I think it was actually step 4. So here I'm connecting the edge of every active hexagon to the edge of all of the other active hexagons that are near it. So this is kind of anarchy. Loads of things change too quickly. And there's also this kind of like triangular subgrid that's developing. But I thought this was kind of in the right direction because you get these flashes of these really interesting, complex shapes that was sort of what I wanted to go for. So that was step 1. The next thing I did was introduce this concept called layouts. So if you connected every single edge to all of the active edges, it just became quite noisy. And I thought we could do something interesting by having different modes for these things. So if you had 4 neighbors, there are a few different ways that it could line them up, and they're kind of randomly selected. Next thing I did was get rid of the game of life concept. I should really just never mention it in the first place. But I thought it was too much noise, so I tried out a bunch of different kind of ways of generating this kind of randomness. I settled on the idea of a creator and destroyer relationship. So there's one that's going around and leaving a trail behind it, and there's one over here that's not doing much, that's kind of destroying its own path. And yeah, you'd get these clusters of really interesting shapes I really love. So I just kind of didn't stop. Next thing I did was with the generative design book, they had these, they were like quite complicated glyphs. And I thought instead of introducing something more stylistic, what I would do instead is make a double active state. And so it could be off, on, or like double on. And when it's double on, there are 2 lines. So this means that if it goes from like double on to off, these lines have to like diverge and converge in really interesting ways. And the last step was to make them a lot more circular. There was being very triangular before, so this was kind of softening all of the angles. And yeah, I love this so much. It's the proudest I've ever been of a piece of work. I could just look at it for ages. But one thing I did do in the process of this was that I added some keyboard interactions. So you could stop it, and I could get rid of them, and I can make a ton of these creators and see like what they made. But I could also make like one creator and a load of destroyers. And see what that did. Sorry if the contrast isn't good enough for you to see the things going on, but it leave these little bits of trails, which is quite cool. But then what this also did was introduce mouse as an input. So then this is just a straight up drawing tool. And it makes these interesting kind of shapes. And I was doing this one day for many hours. Yeah, I was kind of, I kept coming back to some of these forms, and I was like, shit, I've made jewelry. Yeah, I've since realized that anyone that plays with this demo, they kind of bring what they know to it, so they kind of like see whatever they're used to. I was talking to a biologist once, and he was like, "It's protein strings," and I was like, "No, it isn't." But yeah, I ended up just making these kind of things, and just knew that they needed to be jewelry somehow. So yeah, I came. This project was over, but for our final project at the end of the masters, you could do whatever you wanted. So a lot of people started from scratch based on what they'd learned, but some people, including myself, picked up old projects and just kind of pushed them a bit further. So that's what I did with this. I decided it needed to be jewelry somehow. What's the next slide? Oh, no, spoiler. So yeah, the first thing was like, how does this become jewelry? Like, what's the scale? What's the material? And to me, it always seemed very like wire-formy. I could really imagine the ways these kind of lines would overlap in a third dimension. But I wanted to, at this stage, not be limited by the actual production mechanism before. As I've said before, like, you can keep pushing through if you want to make something, and eventually you'll get to how it's made. But I didn't want to worry about how I was going to make it. I didn't want that worry to impede my vision of what it could be. So I decided that the first stage would just be to try and make like a perfect 3D visualization of what I wanted, and then deal with how I actually make it later, because I know that no matter how crappy that is, I'm going to make it somehow. So it also involved like a really big refactor. This was originally written in P5, which is a JavaScript implementation of processing, which is just like an added layer on the Canvas API, completely unnecessary. And yeah, so I did a few things. I got rid of the weird hacker black thing, and came up with this. So now there's like a canvas on the left-hand side. I want to draw something really nice for you. Hold on. I also added a few features, like you could hover to like pick a new one of those layouts. Yeah, so and I have a render button. Yeah, so it makes something like this. Thank you. This isn't actually as shiny as it is in my current demo. Anyway, so yeah, it also has these two sliders, and these are for depth. So if I bring them down to nothing, I'll be able to explain them a bit more. This first one is for layouts that need to overlap. So if you have something here where they cross over inside the hexagon, I wanted to kind of attach the two edges and make sure that they separated. So that first one, this isn't a great design to show that. You can kind of see that over here, that one's gone up and that one's gone down. And then the second, this second slider was to, you can definitely see that, bring up the inside of anywhere that's doubled up. So with both, between these, you can sort of you can have a bit more choice over how deep it is, and it's kind of random. They're kind of arbitrary rules for me to decide how depth works, but I think they're pretty fun. So yay! I made the thing I wanted to do. I made a perfect. This is how shiny it should look. And now is the point of thinking, how does this become reality? And the obvious thing to think of was 3D printers. Oh no, wait. Yeah, the obvious thing to think of is 3D printers, but how do I get it into a thing that I can 3D print? You already saw the spoiler. I thought I would have to export this as some sort of weird data format, import it into Rhino, which is a program I use for 3D modeling, and then recreate all of the logic I've made in here for how things connect up. But it turns out that 3JS, which is the very commonly used 3D library for JavaScript, that's what's making the demo. You can export STL files directly from 3JS. So STL files are 3D object files made out of triangulated surface, triangulated surfaces. So that's what 3D printers can use to print things. And there's an add-on for 3JS, which means you can export it directly from that. So that means you can, like as a JavaScript developer, can make 3D models that you can print without ever having to touch any 3D modeling software. That is extremely cool and very easy. So that's my first practical tip. And then it's like, how do I make it into reality? So the most common, like non-commercial 3D printers are like these ones. They're extrusion-based. So they have a reel of plastic that they melt and then kind of excrete it in layers and sort of build up the model. The issue with that is that I wanted to make these things in precious metals. Like, it'd be fine if they were just in plastic, but they're the kind of thing that really look like wireframes. I really felt like they should be silver or gold. And the way you would usually do that with like a 3D printer is that you would 3D print the thing in plastic. You'd make a mold of that in rubber, and then you'd cut that out of the mold, and then you'd make a wax copy of the thing. Sorry, this is getting quite complicated. I'll explain that process more later. But you make a wax copy of the thing that you originally had in plastic, and you'd use that with this traditional casting process to make it into metal. But I can't do that with my things because they're so like delicate and windy. You wouldn't be able to cut them out of the mold. So this wasn't really an option for me. What I really want is this. This is actually for steel. It's a direct metal laser sintering machine. There are a handful in the world that do it in gold. I've been lucky enough to see one. It's incredible. So the way that works is that you have metal powder, like really fine powder, and a laser comes from above and just melts the metal, and then brings that down like a few microns, puts another layer of fine powder on, melts it again. So you end up with this vat of like gold powder, and inside of it is like the perfect final piece that you want to make. Yeah, I can't afford that. You may imagine, extremely expensive. Maybe someday, hoping for that lottery win. But yeah, that wasn't really an option for me. But what we did have at university were a couple of these machines. These are Formlabs Form 2s, and they are based on stereolithography. So they work slightly differently to the extruded ones in that they have a vat of liquid resin, and they work the other way around. So the build plate comes from the top, and the laser goes underneath. So it like fuses this material and then brings it up and goes back down as a layer. So it kind of builds it backwards. The cool thing about this is that the materials just have to be like photosensitive resins. So it's a different world from having to have a plastic that you heat up and then goes back, which means that Formlabs have a lot of experimental materials, including a wax prototype material. So I can basically print something on here directly in the wax that I'd need for the casting process, which is amazing. So yeah, this was the first model, just in plastic, not in wax, that I made from a Formlabs printer. You can see the kind of structure behind that. Those will support things, because you can imagine this is being printed upside down, and you can't laser just in midair. So you have to build something for the bit that you want to attach to, but it's removable. These are the second ones. They were far too small and delicate. But these third ones were just about the kind of scale I was imagining. This relates to like 1 millimeter thick wire, which is like a very standard size to make jewelry in. And they just had a sort of like the feel of something that I could imagine being in metal and being really lovely. So this is a video that I could spend several hours talking to you about how to make those things into metal, but I thought I'd, in the interest of time, save you that. So I'm just going to talk over this video. Where's my mouse? Right, so first step is 3D printing, as I'd already mentioned, and then we have to remove all of the we put it in a UV chamber. I don't have to do this step anymore, but it just looks really cool. The next step is removing this support structure. And then I used to take it to this guy called George. I now do 3D print all of this bit as well. But for the metal to get to the end of the thing, it needs to have space to run down, otherwise it will cool before it gets to the end. So you need to kind of make these things called sprues, which are kind of allow the metal to get to the end of the piece. It turns it into a bit of like a tree structure. But yes, it used to be extremely manual, and now I'm so glad that I wrote the algorithms to 3D print it. So it gets this, and then you put them all on this like root sprue. So you have like a whole wand of these wax things. That gets put in a metal flask, which gets tipped up and filled with this stuff called investment, which is like really fine plaster. That then goes into a kiln, and then all of the wax gets like superheated out of it. So you're left with this extremely hot thing of plaster that has a hole of exactly what you want the metal to be in. So then it goes into a casting machine, which is either centrifugal or vacuum-based. And then that's where the actual metal gets melted, that's all silver. And that gets like forced into where the wax was, and that's how you get like a perfect copy of what you're doing. This is how like 98% of all jewelry is made, by the way, on like a lot more industrial process, but you can do it like fairly small scale. So yeah, I have all of these bits. They get cut off the tree. I bring them back to my studio. I do some sanding and some polishing to clean them all up. And then I just list as a pendant, just put it on a chain. And yeah, I have a production process. You may be able to see. I'm wearing one today if you want to see it up closer later on. Yeah, so this was all a great success. I did this all for my final exhibition at university. I know I've said that you should make a lot of things in this talk. I would never advise you to make a light-up jewelry cabinet. It's the worst. So yeah, this went really well. I needed to have a name for this when I produced it, and I really couldn't think of one. But as like teenager, I had this jewelry brand called pentateuch, which is the simplest four-dimensional object. It's like 5 points in 4D all connected to each other. And I was like, oh, I could just use that, but that's like 5. Let's just call it hexateuch because that's 6 and similar to a name I already have. So I went with hexateuch. And yeah, I got to the end of this. I had it on display with the program so people could create their own, and then showed off some pieces. And then after that, I was like, I got to keep going with this. I can't stop now. So I had access to this lovely 3D printer at this university, which I was sadly leaving. And to really progress with this, I needed to get one of my own. So I ran a Kickstarter campaign. Yeah, the 3D printer was only like £3,000. I don't know why I set the goal so high. But yeah, mercifully, it was successful, which was amazing. And the main reward was people being able to design their own pieces. So I didn't give many guidelines on what people could do. I didn't even actually set a size limit, which was a mistake because I didn't have a scale on the demo, so no one knew actually what they were going to get. But these are like most of the pieces I had to make as a result of that Kickstarter campaign. This is all of the support structure that got cut off. And yeah, I thought you couldn't make anything ugly with this program, but I was wrong. It's just, I found that when people were open to being abstract, there were some really interesting things that were made. But when people were trying to do certain things, like what's going on here? It's just a giant D that was like this big. Yeah, when people were trying to recreate particular things that didn't work so well, but there were some things that were just astonishing that came out of it. Like these two in the corner blew my mind. I didn't know you could do something like that with this system. And equally, just like I wouldn't have thought to make this was like weirdly deco in a way that I'd never thought to make. So that was really beautiful. And there were also some pieces that had this kind of weird symmetry, like these were just completely random people, and they'd happened to make two pieces that just went so well together, which I thought was really beautiful. So yeah, nowadays I'm still working on this project. I'm gearing more towards the production side of things in terms of what I'm improving, because it's a wax prototype material. It's not normal wax the way you cast traditionally. The results are kind of inconsistent, so I'm working on bringing all of that in-house. I now own 3 kilns, which is kind of crazy, but you know, that's really exciting. And I'm hexateuch.io if you want to check it out. I'm also working on earrings and rings. I have the only hexateuch prototype ring on my hand right now, so if you want to see that later, come up and I will show you it. gosh, I don't have my speaker's notes now. I don't remember what I was going to say at this point. Yeah, I hope I've showed you that it's not too hard to get started with this kind of thing. It would be hard to recreate this, please don't copy me, but but you can get pretty far with like just a printer and just explore, and then you can build on these kind of things. And also something that starts as like a fairly trivial bit of play, just like a little demo in the browser, can actually turn into a high quality physical product that you can actually sell. So yeah, just to finish off, I've shown all of this has been like my own work so far. So I wanted to show a couple of really interesting things in the space that I get a lot of inspiration from. So the first is, I put this in the wrong place. Nervous System are a pair of incredible designer, maker, scientists from the Catskills in New York State. They've been making generative jewelry and generative jigsaw puzzles for a long time. We do things very differently. I really respect them, though. But this is a thing they released, I think, last year, and it was based off simulations of coral, and they 3D printed. They actually didn't 3D print the mold. They 3D printed a mold for the mold, and then they used traditional like slip casting ceramic techniques to make these really beautiful, really tactile mugs, which are just gorgeous. This is a company called Unmade that are doing really interesting things in the space of like the fashion industry and the textiles industry, and working with big brands to integrate like user customization on their websites, which I think is really interesting and very like high quality work. Finally, my favorite material to work with is glass, which I haven't mentioned up to now, but MIT have made a 3D printer that 3D prints glass. It's like a kiln that keeps the glass melted, and then another kiln, and it's like a kiln on top of kiln 3D printing. It is just bananas, and the outputs are phenomenal. And I think this kind of proves that you can sort of 3D print everything, and eventually we will be able to 3D print everything. And I don't know about you, but that's a world that I really look forward to inhabiting. Anyway, so that's enough for me. Thank you so much for listening.